So, hello. Today I will be explaining you about my topic which I have chosen is predictive maintenance and manufacturing which is required. So, first introduction just like there. So, what is maintenance? Maintenance is the process of preserving the equipment which are functional at its functionality it performs to run the industry and which requires a regular inspection, repair, and replacement. So it ensures that the machine operates effectively and reduces the likelihood of unexpected breakdowns. And so it could be done by some data things such as sensors, which includes the temperature, vibration, and torque, which could be important in this temperature, vibration, and torque way to anticipate the failure before it happens. Yeah, so there can be different types of maintenance which can be reactive, preventive, and predictive. So, the importance of this uh, wo- in this would be some operational efficiency, cost reduction, and safety and compliance of the workers which are working there, and and it would also impact the productivity of the people and the machine both as well. So the shift towards the predictive maintenance from reactive to predictive. So in earlier times there would be a regular scheduled maintenance, but yeah, in this time we can predict the maintenance before um before something happens. So yeah, using the real time data and and machine learning. So in business value, the predictive maintenance has a cost, saves many costs. So first we would talk about the some factors which are just like there here some there here this is the data set. It contains timestamp sensor readings which are from the temperature, humidity, etc. Failure levels and the remaining useful life can be predicted from this. So this is the data set. It contains humidity, vibration, oil level, power consumption, etc. So our why main objective why ML is suitable. So it would predict the equipment failures earlier. It would optimize the which is used to predict when the equipment is likely to fail, and proactive maintenance task, failure probability estimation, and even optimizing the maintenance. And we can also dynamically schedule the maintenance of the machines, and resource allocation can also be optimized, just like extra spare parts and people who are working for them. Mm. So yeah, so in the Chris name we are defining the problem. Um, just like the Christian is the business understanding of it. So the first problem definition would be just like here we have the to optimize the equipment failure and maintenance schedule. Uh, so here our business objective would be just like minimize the unplanned downtime and optimize the maintenance schedule. as well as prolonging equipment the lifespan, predicting the equipment failure in advance so that something doesn't happen, enhancing the efficiency and reducing the maintenance cost as well. And here we also have some data understanding, which can be the data collection, sensor reading, temperature, operational metrics, and maintenance log, etc. Exploratory and data which would identify the patterns. Mhm. In this, we can also say that um, there is data business objective. This is the data understanding and data preparation by cleaning and normalization. And we also have to select a model for this. Uh, so yeah, we would mostly go for random forest, support vector machine, and time series analysis. And model like an historical data model are also trained and ensuring that it would not precede the equipment failure and hypermetric tuning. After the evaluation, we could find the accuracy, precision, F1 score, user, and etc. So deployment, the integration of the machine system and can be in real-time monitoring and as well as monitoring and maintenance. Uh, yeah, and some key feature would be the sensor readings, operational and time series, and failure labels. It's earlier how much failure used to avoid and the through which we can take the remaining useful life of the system. So in ML system design, so in solution plan we have to split the data and then model performance metrics and hyper parameter tuning of the data. And in ML system design, we would cover the process just like data pre-processing, which is handling missing data, outlier removal, and normalization. Then we would select two random forests as well as gradient descent and LSTM for the time series. So some of the potential risks could be the data quality issues, which would be the risk of the data which reduce the model accuracy, or the mitigation, which robust preprocessing technique in which we validate the data. And maybe it could occur in overfitting sometimes, so that the data is failed into generate new data, mitigation and scalability. So here we have some future scope. We could also integrate the IoT system, and we could also use some deep learning model, but this is the future perspective and it could help for cost optimization. And further, I would like to add that this is the diagram through which we will conduct the process and work, work in workflow. First, there is data collection, data pre-processing, feature engineering, model selection, failure at time estimation, real-time monitoring. So we actually consider most of the model, but from here we can see that mm, the the random forest K was the most accurate, which was 0.984. And then it also random forestry was the most accurate, but the logistic regression accuracy was lower. And K next, according to the neighbor, it was 97. So we would consider the 98. Yeah, so this we can say that actual versus the tool where what is the type in this, just like each unique type of accuracy in this, some of the things which are here. So type of machines which are high, low and medium. um and then there are some failures which are heat disparation, some no failure, but don't know how the machine got failure. But yeah, it did not predict as much as a tool where a failure, which we will do next. So thank you guys.